Stuff. Basically, if you want to get the slides and any recordings that I make, which I just realized I'm not recording, you can do tinyurl at maglinux 2016. I would give you the full URL, but I get the feeling that's a little harder to write down. If you're wondering, the domain for that email address is my site. So I am doing something important, probably. Okay. This is just going to be like an hour-long memo. I think. All right, it's actually picking me up. That's good. So, so how many people in this room are actually making a game right now? Just show of hands. Okay. Put your hand up if you're not using Unity. Hey, that's actually kind of cool. Are you all making your own engine from scratch, or is it like maybe Unreal or Game Maker? Anything? Just shout it if you have it. GDX. Oh, nice. I remember using that like, oh man, that was like in 2011. And then I kind of ended up working on like C++ stuff, and then now I sit in C. Yes. I was a little sad to see that they used GLFW for the windowing, but other than that, like I used that raw like directly with LWJGL back then, and it was always really nice. A lot of my C# wrappers are basically copycats of how they did it because it was so well designed. So, so, well, we'll get to that. Anybody using XNA by chance? Or has anybody used XNA at some point other than you? Because I know you have. Okay, cool. Because, let's see. Yeah, I'll get into that a little bit. Because a lot of the slides that I'm going to be talking about, there's not a ton of code. There's like a few slides, but they're all the same code edited in slightly different ways. And a lot of it just has to do with generic, like, it doesn't matter what engine you use, don't have 6,000 textures that are 128 by 128. You know, we're in an age where textures can be like 1K. Like, technology's been able to do that. So you'll get the idea. I'm just gonna start now. Basically, other than the downloads and the email address, the first internet handle is for Twitter, and the second is for Google+. Basically, Twitter's for dumb jokes, so that's where that goes. And then Google+ is where I write lengthy things. An example right now is I'm actually working on an update for the PC version of Fez. And every week, I've actually been doing updates on some of the technical things we've been doing, like even sometimes it's really basic things like making sure that the controller support doesn't suck, i.e. let it be configurable, because no games do that anymore. And then there's some technical things like our attempt to do multi-sampling and the fact that it just didn't work for a 2D game. So if you're interested in that, Google+ is where I dump all that text. But I should probably introduce who I actually am. So my name is Ethan Lee. Most people will know me as Flibbit, because that's just the name I went as for so many years. My experience is with Linux games and Mac games, so you'll notice that I'm on a MacBook right now, ashamedly. And most of my work is in XNA games, so I work on a project called FNA, which is basically XNA reproduced as accurately as I possibly can. So there's another project called Monogame, which tries to be like the successor to XNA on its dead, and for ports, I needed something that was exactly like XNA, down to the most ridiculous things that XNA does, and there's plenty of crazy things it does. And throughout developing that, among other games that were not XNA, I've worked on other things like SDL, and I've actually contributed to some extensions to the OpenAL soft library. I've done a lot of reverse engineering for projects like Mojo Shader, which I'll talk about later. And as far as the actual games that I've shipped, I've been doing this for almost 4 years now. It'll be 4 years in April, and I've shipped about 36 ports. And that involves packages, sometimes up to 10 different packages. So if you look at the SKU count, a SKU, for those who don't know, is an individual package. And I am actively maintaining about 121, I think. And there's a couple more that I ship that I don't maintain, like the Mac App Store version of Transistor, because I don't want to do Mac App Store stuff, so I let Supergiant do that. And there are a couple, people latched to like IGF and Indiecade. There are a couple grand prize winners and nominees. I didn't want to track all of them because there's just too many games. And when I mean too many games, I really mean it. I have no idea what that looks like up there. Ryan Gordon calls this like the NASCAR jacket for those of us who are like freelancers. And this is my attempt at that. This doesn't include things like Nukem 3D or other games like that, but that's sort of my attempt to kind of show you in one frame what it is I've been up to for the last few years. So on the subject of this actual panel, even though you're here and you're presumably interested in Linux games to some extent, you probably still have that question in the back of your head, which is, why should I bother doing any of this? Because there's still, you compare like market share on Wikipedia, and it's obviously some really low number, or it's like, porting stuff is hard, or working on Linux is hard. So if you're looking for reasons, I might have a few. This is the obvious one. Really, it's great that we can just sort of cheaply say, look, SteamOS exists, so obviously you should support it. And to be fair, if you need a console platform that is not the Xbone, this is a really good example of that. But I am happy to admit, and I even saw in the description, like I wrote that description before it had even come out. I knew it wasn't going to make a huge splash in the business, but one of the big things that people will counter this with is, the hardware isn't great. Like you look on the site and you look at the store page, it's like the baseline is Alienware. Like I assume many of you are PC gamers and know better. So really the criticism is, how do we get mass market hardware that is cheap and exists in a lot of people's living rooms already? Because the idea, like when you switch to Linux on the PC, is you just install it and you're done. So something really cool happened a couple months ago. I don't know if you've seen this. Some really talented, intelligent, and handsome people at Failoverflow got Linux working on PS4. And back then, they just basically had like the kernel working, and then they had like a little software frame buffer, which is what you're seeing in that shot. But even better is that like a week later, they got graphics drivers working. So they actually had 3D Linux games working on a PS4. And while it's still very much in progress, and if you are capable of doing things like Linux kernel development, I encourage you to help them. This is a really, really good example of how open the platform can be to the benefit of someone other than just the vendor. Like, yeah, okay, the PS4, they're very friendly to people who are not AAA, but you still have to go through somebody. Whereas SteamOS, as long as you have the ISO, and you have the ability to make a game, you just target it. And having hardware that is mass market that works with SteamOS is a big deal. And as far as the games themselves, I'm sure none of you have seen posts like this before. Basically, the really big problem with posts like these is that it shows how multi-platform is less of a marketing thing. Like you think what's difficult to sell is you're trying to market to Linux users, which is a small market, and nowadays they have a choice because people have actually been picking up on this. But I would say, as someone who ports games professionally, I've never thought of it as a market thing. And in fact, if you ask me what my ports even sold, I would have to go look it up, because I think I've looked at the numbers twice ever for like 2 games. My whole point, and your whole point, if you're going to do this, is less of a marketing thing and more of a user experience thing. Because if you are in a situation where, like these guys, they have Linux and they don't want to move to Windows, there are also people who there are probably a lot of you in here who are like, oh, I would switch to Linux if I had something like a game or like Photoshop or something like that. So knowing that there is a considerable amount of people, and it may be you who's like this, why would you act as one of the roadblocks to making people switch when you know that that's what they want to do? And this is the really big point of trying to build a new platform, because it's really a matter of being there to actually build it. You can't depend on someone else to build it. You have to actually contribute to the new platform. You can't just say, oh, Valve will do it because they're Valve, because obviously it's not working very well for them. It's getting better, but it's not exploding just magically because they're Valve. It actually requires developers to be making interesting things for the platform. And if you do it after the fact, then you're doing it way too late, assuming ever, if you're the sort of person that assumes it has to be a market thing and not a user experience thing. So being able to get Windows users the opportunity to have whatever they want, wherever they want, is a big deal, because especially with Windows in the state that it's in now, I mean, we thought Windows 8 was going to be the case where people would switch, and people thought Windows 10 would be sort of a Windows 7-ish backtrack. Turns out that wasn't really the case, and wonderful user experience things like this taskbar, I think there are a million ways to kill it, and I think they've all been patched out. Same thing with all the privacy things, and people are looking for ways to not have to deal with that, both as users and as developers, because you'll see like that top if-def. For those who don't know, I think in the original Windows 8 API, that extra 0 had to be 0. It didn't do anything. But there were tons of things that developers had to do just to get their game booting on their machine, even though the old APIs were still there, but they just couldn't because there was this arbitrary cert process that they had to go through and objectively make their games worse because they were spending way too much time doing absolutely nothing for no reason. And so if you put yourself on a platform where these things are going to be commonplace now, because we've now seen it twice in a row where they do this, you really are putting yourself in a position where you're not spending your time making games anymore. You're spending time porting your platform to the platform you're already on. And that's just the PC space, because if you think about, say, the living room space, we have problems like this. And anybody here really upset that the iPhone and Android took over Nintendo's place as the portable gaming masters, basically? Quite a few of you, actually. Guess what? This might be around too. If you're thinking that the consoles are bad now, Apple TV is actually picking up. And as someone who ships for Apple products, I can tell you that it's a very likely chance that this will end up taking over in the same way that iPhone did. Obviously, there's things like the 3DS and the Vita, or, well, maybe the Vita. But the point is that if you make these platforms essential and you're stuck working on them, and there are games like Binding of Isaac, which recently had to go through the cert process over some political certification requirement. If you're a new game developer, this stuff is impossible to deal with. And that's just on this cert process. If anyone's actually developed for a mobile, the concept that you would want a mobile development experience on a console is ludicrous. And so we need to be able to do something about this, and that's what I'm going to be talking about today. So some of you are on Unity, some of you are making things on your own with like GDX. I point these out as things that will make it easier, but everything that I'm going to be talking about today applies to everyone, even if you're using things like this. Because sometimes it's a matter of getting just general performance things to work, and then there's things like the middlewares, which I'm going to have quite a few slides on, because, oh boy, there's a lot to talk about there. So just know that if you're using something like this, you're really not immune to a lot of the pitfalls, unless the engine developers did obscene amounts of work to hide that from you. And even then, it probably has bugs. So just get ready for that. For those who are making something, and you're using like native code, you'll know that Visual Studio isn't on Linux, and that might be one of those. It might be another case of the software. Like I would be on Linux if we had something like Visual Studio, but I would like to point out that when you are doing multi-platform development, you should not feel obligated to develop on every single platform. Like that makes no sense. You shouldn't. Like you're making a game, and then the rest should just be targets. Like I've shipped about 25 XNA games for the Mac. I have done absolutely zero development on the Mac. Zero. None. I don't even build on the Mac, because what I do is, because it's C# and I can just use the runtime, I just do all the development on Linux, and that one binary actually works everywhere. So I never develop on a Mac, because the Mac development experience is kind of wonky, even if you're a Unix programmer like me. And so the whole point of multi-platform is that you can make all these platforms targets. You don't, it's like thinking that you have to develop on a PS4 to ship for the PS4. So if anyone tries to give you the impression that you have to develop on Linux, you don't you don't actually have to. You may use the debugger at times, and you obviously have to build on the platform for native code, but you really don't have to, dump everything you've done before and start over. That's a complete myth. And really, the whole process of getting on multiple platforms is not necessarily doing everything over. It's just a matter of taking your stuff that is not portable, making it portable with things like SDL, OpenGL, and some small libraries that I'm going to talk about in a second. And then from there, your Linux build is just a matter of building it and then debugging it if your code is a little wonky, which does happen at times. And I'll get to that toward the end when we talk about debugging. The big point I want to talk about when it comes to making multiple targets in terms of content is that you shouldn't change your content. There's a very big temptation, especially if you're dealing with shaders, there's a great temptation that you should be like, oh, I have HLSL for Direct3D. I should have GLSL as well, so I got to write the shaders again. And I've seen people try to port like this, and it is just a nightmare. The whole point of your engine is to take the data, which you've made, it's just content. Even if it's shaders, technically it's just content, and make it work wherever it needs to be, because it's just data. If you're changing the data, you change the problem. And in the case of porting, when you make multiple versions, you're not just changing a problem, now you're adding a problem. So every time you do a trivial change to the content, you gotta do it twice. And if that involves actual work other than just hitting a build button, that's like, that you will never want to change your content. Your game's gonna be worse because you're just reluctant to do anything that makes it better. So do whatever you have to do to make the content work wherever you have to. Even if it means taking your shaders and making it work with your homemade intermediate language. Like if you go to the Steam Dev Days talk for OpenGL, they actually talk about how they take their shaders and just rewrite them at runtime to be like GLSL because they don't have to write it more than once. It sounds complicated, but the work that you put into making one version of the content will pay off for years. And of course, the way you do that is by using portable things. So if you have like an image loader and it's like this horrible C++ mess that depends on like 16,000 versions, a really good way to fix that is to just use something like stbimage or load.png where it's literally one C file. You just bundle it into the project and it just works. You don't have to depend on anything. It doesn't have any actual, some of them don't even depend on the C runtime, if you can believe that. And being able to just hit build and not have to worry about wrangling libraries is really, really helpful in both getting your build to not be a horrible mess and getting your content to be consistent wherever you actually are going to be. So as far as the actual process for porting, a lot of what I'm talking about is kind of glorifying most of the process, but the whole point is that you're really just hitting build over and over and over again until it compiles. If your game is big, it will take a while, because if you're not used to putting your platform stuff in other places where it's isolated, you're just gonna be sitting there forever. I've spent weeks just getting one game to compile. Sometimes it really does take that long. So if you're worried that you're not writing portable code, do it now, because if by the time your game's done and it's this giant mass of source code that you don't even remember writing because it's been so many years, this gets really miserable. So do whatever you can to make it so that this process is as few makes as possible, because I get paid to type make over and over again, but odds are you are not. And if you're starting from Windows, because the thing is, I work on Linux, and so when you see things like Windows.h and Direct3D9.h, it just obviously doesn't show up, and so it's an automatic error. If you're starting from Windows, if you want to get your Windows game running on SDL and then get it running on OpenGL, you have to kind of find those headers and comment them out and hope that those are the ones that you do leave in are portable. I don't have a lot of experience with this, but if you have a lot of headers everywhere that are platform dependent, then you get to play scavenger hunt in addition to typing make over and over and over again. So the way I fix issues when compiling is I just stub everything. There's a strong urge when you port something, you see this code, even if you're not even, you might look at some code and be like, man, this is terrible. I bet I can make this better. Don't do it. Leave the code as terrible as it was. Just take all the stuff that isn't portable and just stub it. Because you're already spending enough time getting it to build. Building takes forever on a new platform. You really don't need to be sitting there being fancy engineer trying to do things all at once, because there's a chance that your code's not going to work anyway. So the way you do it is you just do if fix me port, and then throw all the platform stuff, and then just have something like an assert. So when you boot it, that assert gets hit, and you know that you're supposed to be working something at that particular point, and that's where you can start. Because if you just have code everywhere, you don't know it's actually broken. It could be anything. Because not only is your new port code not going to work, there's a good chance that even the stuff that you thought was portable is broken too because of things like weird, wonky memory management or architecture dependencies and things that I could list just endlessly that you could never think of because you didn't have a platform to tell you that what you were doing was dumb. And on the note of fixing this, I'm going to reference a 90s cartoon that nobody remembers anymore, sadly. And the way you fix it is by writing something like this. What you do is you write like a platform.h somewhere. You write all the functions that you previously had on portable. So in the case of like, oh, well, actually, no, it's not going to work. But basically, if you have like get special folder and it's like the My Documents folder, you just wrap that in something called like get savedr. It does that for Windows, and then you can just fill in the blanks for Linux when you get there. And it's, I mean, and it looks great, right? What you really shouldn't do, and the big point here is, note that I wrote ifdef fix me port, because you may be tempted to do Win32, and then you're going to write something like this. I see this all the time, and it is just the worst thing to debug. Mostly because, you know, if you look at this, for example, you'll notice that for Linux, it's just the else, and so on all of your platforms, you'll just have, like if you're on Apple, you're going to get a Linux path for Apple, and then it might not work, and if you're going to the App Store, it's going to fail cert immediately. And users will have no idea where the hell it is, because it's in a completely different place from what they're used to. So obviously, some people will look at that and go, oh, it's the else that's a problem. So what you do is you just do Linux. Now it's fixed. Great. We'll ignore the fact that this actually is a silent, this will build on other platforms, but because there's no code to actually do what you're supposed to do, it just returns garbage in this case, because it's just, you know, that uninitialized buffer. And stuff like this is impossible to debug. Unless you just magically have in your brain every single thing that you ported and know exactly how it would behave if it doesn't, because I'm sure all of you know exactly how uninitialized memory behaves. It's like, it's such a mess. And then it's like, and then someone will look at this and be like, oh, I know what the real answer is then, is that you add an else and for the new platform, and now it's there. Now it's completely robust and perfect. I can't wait to maintain this for the next several years. All good. Beautiful. But of course, what you'll notice is that, as I mentioned, I cited Apple as an example multiple times because everything I talked about just now is just any platform. There's no Linux stuff in there anyway. It could be for anything. It could be for the PS4, it could be the Xbox. There's all these things that you're going to have to port every single time. That's why having that platform underscore or whatever API is really helpful. But if you're looking for sort of things that are Linux specific, there are quite a few, and I'm going to talk about them now. The first one is going to be one that everybody has no idea what's going on unless they just magically know this. I feel bad about this header because I actually love the file system for Linux as a user, but as a developer, it makes me want to kill myself. Because everybody that develops in Windows does not give a crap about their file name case sensitivity. Because why would you? It's all case sensitive. Who cares? Except I care because I had to fix it later. And so if you have something like a content folder and you just reference files, if it's a wrong case, like literally the letter C in there, uppercase and lowercase, those are two different paths. And so you have to be able to find a way to make it not a problem. And two ways that I recommend are, you can either use pack files. So if you just like pack all your stuff into one archive, that's helpful. And there are libraries like PhysicsFS that I used for the 2.2 update to V that you just use a zip file and it treats it as a pack file, and it's really cool. Or you can do what Valve did and some other AAA devs do, is that they just force all the files to be lowercase, and then they write a wraparound like fopen that just forces all the letters to be lowercase. It's a little bit brute force, and I don't recommend that, because if it's broken, I would not begin to understand how to debug something like that, but it's an option. And since I imagine many of you are Windows users, there's this little meme feature that Linux has called security. It's a lot like that privacy feature that they deprecated in Windows 10, but the point is that they actually have this on Linux, and so you have to be a little bit more conscious of what you're doing with the file system. So if you're one of those games that writes your saves to the game folder, like just save.sav next to exe, you actually cannot depend on that like you can on Windows, because you can just write to program files and nobody cares. But on Linux, if they have it on like the root storage directory, like usually it's like user share games or something like that, and the system will actually fail to even open the file, and you could possibly just be writing into a random buffer and just crash horribly. So try to write to an actual save or config folder, and those are the two that you have to target. It sounds weird because you have this thing like XCG data home, like what is that? In the defense of this standard, it's just those two. So if you're used to games on Windows where it could be in the game folder, or my documents saved games, or saved games, or app data roaming, app data local, program data, sometimes even the registry. In this case, it's always these two. And honestly, if you want to be fancy, you can target both, and I recommend doing that because your customers will give you like bonus points for that. But if you are in a position like with XNA, we just target XGG data home because it doesn't have a concept of config and data. Like if you just go to one, they're not going to hate you for it. Like Unity actually only targets XGG config home. So if you're on Unity, it's like .config, Unity 3D, your game, and then your data. So sometimes you can just dump it all into one, and they won't hate you for it. But if you can get it to be both, they will appreciate you for that. And it is actually really hard to write code that does this properly, so there's a gist. Just steal it. Just take it and just, it's a single C file, just like any of the other good single C file. It's just 2 function calls, one for each, and it just works. The second big problem is that graphics programming sucks. You'll notice that I did not specifically cite OpenGL, and I say that because OpenGL is just a slightly worse case of something that is just objectively bad everywhere right now. Because if you're doing Direct3D 9, for example, and you're calling like a draw call for every single triangle, like if you're like, I'm looking at all the 2D game programmers out there, if you have like a draw call for every single sprite, and you have 2,000 of them, you're going to be sitting there for such a, like, to give you a scale of just how slow it can be, I have a benchmark for sprite testing in my FNA like mini tests, and drawing 2,000 sprites, even though they all use the same texture, it takes like 6 milliseconds for 2D sprites that are like this big, and there's no depth testing, there's no blend. It's super, super slow. So what you have to do is take all your vertices and all your sprites, get them all in one texture, get them all in one buffer, and then do all the drawing at once. Your game's going to be so fast. Like to go back to like the 6-7 millisecond draw sample, if you set that to deferred instead of immediate, which is what it's called in XNA, if you get it all in one buffer, even if you have multiple textures, it takes like 1 millisecond, if that. So it can improve your performance immensely, no matter what your API is. So if you have like fonts and you're drawing every single character individually instead of buffering them all at once, you're just going to be in a living nightmare, especially if you're doing like a game that has a bunch of particles in it and you're doing them all individually. So things like that will make your game slow. And there are things like glget that is also slow, because how graphics drivers work right now is that they all run on a thread. And when you call like set blend state, it's not like magically just setting an amorphous blend state and sending it to the card. It's doing something called generating command buffers. Like if you're familiar with like the DirectX 12 and Vulkan, the hype around that, the idea is that it gathers all these things in a format that it can actually send to the GPU. So if you are calling things like glget, what it has to do is it has to run all the commands that you did before, which it may not have even started yet, and then after it's all done, it gives you the data back, because it won't be accurate if you don't do that. So if you call glget, if you call it a lot, especially if you're trying to get like texture data where you're sending these giant blobs of memory, your game's going to be super slow. And a lot of AAA games have kind of suffered from this because their code for some reason depends on it, and sometimes it's needed. I think I've seen it used appropriately in like 2 cases ever. One was getting a render target to save to a file, and one was like something involving compute shaders and buffers. Like, I don't imagine you're working with that unless you're at a AAA scale. There's something called redundant GL states, where basically if you call blend multiple times and you're not actually doing anything, sometimes the driver just straight up breaks. Like, a really good example was when Tom shipped Axiom Verge, there was this really weird bug on this weird AMD hybrid GPU where the character would just have this giant white box around them. And it's like, well, obviously that's wrong because they're supposed to be alpha blend. But what was happening is that he was setting a blend mode to like additive or non-premultiplied or something like that, not doing anything, and then he called alpha blend, and then he was doing the sprite. And that actually broke the driver. So what you have to do is gather all of your states in such a way where when you're actually drawing, that's when you set the state. And you can do things like state shadowing to make it so you're not doing things redundantly. It looks terrible. I know it is kind of dumb that you have to constantly check when the GL could be doing that, but it's really worth not breaking your stuff. And also, in some cases, even though it's just like a blend function, sometimes not calling that over and over again will actually be a speed up for you. And if you're looking for something that slows down and also breaks, there's threaded GL. If you're doing something like Direct3D on a thread, it only works out of luck. On OpenGL, it will not work at all. If you try to do threads with like multiple contexts and all this stuff, I actually have in the documentation of FNA, there's a threaded GL mode. And I actually wrote in the documentation, if you turn this on, you should feel bad. Because there's no reason. The driver already runs on a thread. It's already doing things that you couldn't possibly understand, and you're trying to broker all this stuff through all these threads. You're screwing your game up immensely. And so you have to just knock that, you just have to get rid of it. Put it all in one thread. Even if it's on a thread, it has to be on that thread. You can't be fancy about this because it's just breaking your game for no good reason. Because the driver's trying to figure out what's in the right order, even if it's technically sequential if you're really clever about your threads. But it's just so broken. So don't do it. Because I can't, if there's the top 3 things that I make my money on, threaded GL is one of them. If something has threaded GL, I'm like, I just made $5 grand. Ooh boy. So all y'all in middlewares, guess what? You have it harder than everybody else because all of them suck. All of them. Every single one of them sucks. I don't care if you're going in your head right now saying, oh, I'm sure he's not talking about mine. Yes, I am. Because even the ones that you would think work on multiple platforms because they have so many games behind them, the only ones I've ever seen work consistently is like Bink. If you're familiar with like Bink or Iggy, or the ones from Rad Game Tools, and the reason their stuff is so good is because they've been making that library since 1997, and they have 13 platforms that they have extensive amounts of tests for. I guarantee you, based on the things that I have seen, that some people who make millions of dollars with middlewares don't do any kind of testing at all. Any. And so, oh, and I really should point this out. If you're using something like Osmium, or you have a web browser in your stupid video game, you're done. I worked on a game that used Chromium once. I wish I had charged double just to make myself feel better about it, and I'm never working on a web-based game again. Never. If it uses Chromium or Osmium, I actually, literally after that game, someone came to me and said, hey, we have this game and it uses Osmium, and I went, if you remove Osmium, I will do it. And to be fair, they actually did it, and of course their game worked a lot better, even on Windows, after they got rid of Osmium. But I cannot emphasize just how difficult it is working with these libraries. Even just getting a web page on a texture, not even interactable, just getting a surface to render took me a month of work. And I shipped 14 games last year. I like to think that I can work quickly. Chromium was one of the worst developer experience I've ever had in any field as a game developer ever. And so, if you're using this, don't expect me to help you. All I'm going to do is laugh and say, your video game has a web browser in it. I don't know what's wrong with you. And in the case of middleware, this is literally from one middleware. I would just like to point out the one that happened to me recently. I swear to God this is true. On a specific platform, they must have platform-dependent code because a middleware that costs thousands of dollars and works specifically audio did not have looping sounds. Like, I guarantee you, even if you're not a programmer, I could sit you down for an afternoon and get you to loop sounds. You just go to the end of the WAV file, and then when you hit the end, you go to the beginning. It's real trivial, and yet somehow, on a specific platform, they didn't have looping sounds. And this costs thousands of dollars to license. And so, and stuff like this happens all the time. These are not isolated cases. The random crashes, they're only random in that I can't debug them. But they just happen all the time with every game. And some of the hacks that I do are really, really unreasonable. Like the one that crashes when the game's silent, the way I fixed it was just by not calling the update method until the game actually is supposed to do something. It makes no sense that a game that doesn't do anything crashes when you call something that doesn't do anything. And the thing is, I have to debug all that with this. This is the debugger. Imagine spending your life trying to solve a black box with that. And to be fair, I'm mostly just putting the slide up as a punchline because I actually like this interface. But I imagine many of you are used to things like Visual Studio or the Unity debugger where it's visual. And there actually are some visual plugins like CGDB and Qt Creator. I only cite those as things that people tell me to use after I tell them that I actually used vanilla GDB, but I've never actually used them. Because the thing is, if you look at the bottom half of that slide, I'm almost entirely sure that that's everything I've ever typed into GDB. So like this slide took the longest out of all the others just because I had to remember what I actually typed into the debugger. Because oftentimes, like, it's usually the first 4 and the last one. And the other 3 are when I'm doing something particularly weird or some function is just like a horribly templated mess and I need a breakpoint. But really, if you're stuck using GDB at some point, just use this cheat sheet. I guarantee you'll be able to debug just as competently as Visual Studio just by using that cheat sheet. You don't have to know what it even means. Just do it and you'll figure it out in like an afternoon. But of course, if you're a multi-platform developer, you would like to avoid bugs like these so you don't have to use GDB. And so there are things like static analyzers and graphics debuggers that you can use on Windows that help you find a lot of the crappy bugs. For example, if you have something that just magically worked on Windows, it might not work on another platform because it's not quite as lenient to certain things, particularly memory management, which we're going to talk about in the next slide. And the static analyzers, John Carmack talked about this a few years ago, and I'm amazed that people didn't pick up on this because it's John Carmack. He uses these all the time, and he pays good money for things like PVS Studio, and as do a lot of other developers. And if you're on Visual Studio, like a new one, I think the Microsoft Static Analyzer is free now. If it's not in the Visual Studio by default, it's in the Community Edition, and their tools are very good. It used to just come with a 360 SDK, but I think they now just have it available for Windows by default. So if it's not in Visual Studio by default, go find the Community Edition because that's where it is. As far as graphics, if you're working with Direct3D, you can actually still use API Trace and sort of figure out how to make your game faster there, and then move to OpenGL, and then you can use OpenGL with API Trace, and it's just basically it's the same interface, just different calls. And then there's other tools like Voggle, which I wish I could recommend, but Rad and Valve kind of stopped working on it because Vulkan was picking up. And now they have a tool that I think is called Glaive, but I mean, because the thing is, Vulkan shipped like 3-4 days ago, I think, and I don't know. Technically, there's something called a tracing tool in the SDK that they provided, but I don't know if it's called Glaive or if it's even the same tool. But there is a tracing tool in the SDK if you decide to use Vulkan. If it's named Glaive or if it's not, sorry if I confused anyone. But there's one tool that I really want to talk about. It's called Valgrind, and it is the best thing ever. If you're looking for software that is Linux exclusive that will make you switch to Linux, Valgrind is it. Valgrind is I've fixed way more bugs with Valgrind than any other tool I've ever used, easily. I don't have to count. I just know objectively, Valgrind finds bugs like crazy. You will think your code is absolutely beautiful, even if it passes the static analyzer. You will run through Valgrind, and it will tell you that you are the worst person to ever exist. Because what it does is it runs your program in a VM, and it tracks every single little thing you do with memory. Everything. Local variables allocated with dynamic memory, things that are freed, things that were freed and then you access later. It will actually tell you that you did a bad access on things that was previously freed, and it will even tell you where you allocated it and where you freed it. It gives you traces of everything. And that data is super, super useful to have, especially if you're like me and are working with code that you don't actually work with all the time. So you're just looking at this thing that just randomly has weird behavior, and Valgrind just makes it so clear and just by running it once. The downside is that if you're working on something like Unreal 4, this is definitely a tool where you run it and you go out and get dinner. If you're working with like a 2D game and you're not calling malloc and free a billion times in your frame, it's probably going to run at 60. It might dip every now and then if something crazy is going on. And if you have threads, it's going to be slow, but obviously because you are all very intelligent programmers and have a single-threaded mode in your threaded game, that will not be a problem. And I want to give an example of just how crazy things can get if you use Valgrind. There was a game, I worked on the Linux and Mac versions of They Bleed Pixels last year. I think it was last year? Yeah. And they had this code. This is not the actual code, so if Andrew's watching, don't worry, I did not publish it. Basically how the game works is that whenever you start a level, it calls reset. And then if it's a level with a cutscene, and it knows it's a cutscene, it calls 1 when you start the level for the first time, and then every time after that, it just calls it with 0. And so you're not playing the Bink video every single time you reload the level, because the game would be just horribly slow if you did that. And I found on the Linux version that the videos just played at random. Like even if the level, like I couldn't describe it. It would just play it. Sometimes it wouldn't. Sometimes it would play for levels that were not relevant. It was very, very strange, and I ran it through Valgrind. And it actually pointed me to this code, which I hadn't seen before. All I knew is that videos are random. And then it pointed me exactly to this point, and it said that show video was uninitialized, which makes no sense, because if you think about how this would work, obviously, whatever you're going to pass, it's going to definitely be a 1 and definitely be a 0. You don't even have to have a variable. It's obviously just a constant value. And I went and looked at the stack trace, because obviously this came with a stack trace, and this was the function I was calling it. There was no parameter. And I was like, okay, is there a default? I didn't, because the thing is, this engine was written in C, and it's very old school, so there's no like default parameters. So I looked it up, and there was a declaration that had no parameters. And I want to point out that I was debugging this at runtime. Remember that, this is at runtime. So not only did it compile, it linked, and static analyzers didn't see it, because all they're thinking is, oh, it's obviously going to reset level at some point, and then the linker goes, oh, there's a function called reset level, we'll just call that. And so at runtime, what would happen is, you would call it with no parameters, and because there was no parameter being passed, that place on the stack was just garbage, and that's where the uninitialized memory came from. And this is a basic case. Valgrind finds way crazier things than this, and it makes it super obvious. So I want to emphasize that you need to use Valgrind with your engine. It is the coolest thing ever, and even if you're using a middleware, if you're finding that your middleware sucks, odds are Valgrind's going to find how it sucks, and you can even give that to them and say, look, please stop being terrible and actually test your code. I have a case right here, and Valgrind, and they can run it themselves, and they can fix it with the wonderful information that it can provide. So seriously, if you know someone that is writing an engine and they are not using something like this, get them to make a Linux version, if only just to use the tool. They don't even have to ship the Linux version if they don't want to. Just have it so you can run it through Valgrind. It's really nice to have. And so I kind of want to wrap up, obviously, as you would when making a game, by shipping it. And the way that I tell people to do this is by, like, the way I usually tell people, because they ask me how to package it, and I go, look, do you have any of my games on Steam? And they go, yes. And I go, okay, steal from that. Just copy it. Just copy every little detail. It doesn't matter if you even understand how it works. Just copy it. And in fact, even in the slide where I kind of give actual details, I put GitHub links in there, because what you do is you target, just like you on Windows, you would target like Windows XP. In the case of Linux, you target the C runtime basically, and it's a 2.15. You don't have to understand it. Just know that Ubuntu 12.04 is where that started with Ubuntu, is that version. And then on Linux, you can actually target 32 and 64-bit with one package, because you can just run a script, and then at runtime, you can just select the architecture, and you don't have to worry about making a 32-bit version, a 64-bit version, and so on. And again, I just put a link. Just steal it. I don't care. And as far as packaging, like if you're used to like Windows, you might have like, I think there's Nullsoft, and then there's, I think, Install Shield or whatever. In the world of Linux, it's Motorset. It's a tool that was written by Loki in the late 90s and early 2000s, I think, and then Ryan Gordon revived it for, I think, Unreal Tournament 3. It's basically a tool that, it's just a self-extracting zip file, so you just execute the zip file as if it's a program, and it will give you this nice little user interface that lets you install to wherever, and then it installs the game in addition to an uninstaller in the folder and a desktop icon. And it's very, very low footprint, because all you have to do to uninstall it is get rid of the icon and just delete the folder if you want, or you can use the uninstaller provided in the install, and it's all automatic. And it's a big contrast to trying to make Linux packages, because if you were worried about doing like, oh, I got to make an Ubuntu.deb, I got to work on an RPM, I got to work on whatever it is Arch uses for package file formats, which is, I don't know what the file format is, but basically, not only is it worse than just using Mojo Setup, but you shouldn't do it anyway, because the whole point of those packages is because those packages were specifically built for the distro. So when you think about like, if you're running like Ubuntu or Fedora, you can install like Blender from repository, but the fact is they're not the same binary because they were built specifically against the libraries that they built themselves in the distribution. And you're not doing that. You may be building on Ubuntu, but you're also targeting whoever is running the game. So you want something that is platform ambiguous, and Mojo Setup will do that for you. And so because you're not using something like that, you also have to ship the libraries, which it seems weird that I actually have to say you have to ship the libraries that you use with your game. But a lot of people don't realize that they have to do that. And so just make sure whatever DLLs you're linking to, just make sure they're in there. And make sure that they don't depend on too much, because you have to, remember, if you have to assume nothing. So you have to gather all the dependencies if the tree is large enough. And so I have one more good idea, bad idea. And that is simply that, well, let's look at SDL, for example. Because this is the SDL dependency tree. For those who don't know, this is basically the C runtime and nothing else. And for those who want a little bit of trivia, on Windows, SDL does not even link to the C runtime. It has very little dependency footprint, very little. And it's for a very specific purpose because it's hard to distribute games that depend on things like that. I mean, if anyone who's on Windows here, how many times have you seen that window that says installing VC Redis 2010, 2012, 2005? I'm sure you love working with that. We don't deal with that crap because we just ship the dependencies and it's just compatible and you don't have things like this as long as you ship the libraries with it. And so it's like libm for math, libc, pthread, I'm sure you know what that's for. And then DL is basically the way that they load dependencies like X or Wayland, which is their multiple display servers. And it's a very big contrast to a dependency like this. I don't know if that's readable up there. Is anybody here shipping with monogame? To anyone who's looking at the recording and going, yes, guess what? That's just one of the dependencies. I'm hoping that they will fix this, but I kind of gave them the answer and they still didn't do it yet. I mean, I don't know, it's their choice, but yes, the NVIDIA driver is in that list. And just so you know, this is a good version of the tree. Because there was a point where the GDI version that I had on my system, I swear to God this is true, linked to 2 versions of PNG at the same time. This is normal for a lot of the bad software out there. Don't be like this. And speaking of actually making sure your stuff is usable, please make sure your software is usable. I felt uncomfortable having to put a slide like this up, but I have seen way too many games, and Unity games in particular, that just build and ship it. Like, they don't run it. Just run it once. Like, one time. Just even if you think, oh, it works sort of on my development machine, just run it on a different machine one time. And you will find at least one thing that is wrong. Even I, as someone who ships for multiple platforms all the time, I will still make the effort of running it somewhere else at least one time. And you know, even if you're not really experienced with this, which if you're starting out with portability, you're going to find things like this. Linux is interesting in that people, they want their games to not suck. It's this fascinating thing about gamers, that they actually want good games. And so, you know, they're willing to hack on things with you. And sometimes, like the team that I have on my QA team, like the way that I pick them is that they're the guys who, instead of filing a bug report, will email me a patch for a game that they don't even have the source to. So, and that's pretty typical. Like, I get like register dumps with crash reports that I get. They give you a great amount of detail, and they're very helpful. You shouldn't assume this, because if you're trying to depend on them as a means of just magically fixing your game, look, you're not Bethesda. You can't just depend that people will fix the game for you. You have to actually be responsible and make it work when you ship it. And so use their enthusiasm as a means of making your game better, not just making it worth looking at all. And wow, I actually made some good time. So that's actually all I had. These are just a reproduction of things that I talked about. I actually have some time for questions if anybody has some. I can just repeat them and then go through. Yes?
Do you have a favorite sort of undefined behavior or bug like that you found switching porting from between systems?
The one weird one I can think of in terms of Valgrind, I was putting together a new build of V, and I was just getting the source together, and I was getting it together, and it uses tiny XML. And the way I usually build is that I just link to my system libs, because, I mean, usually API compatibility is fine, and then I just run it. And the game was crashing for some reason, even though it was a shipping build. And so I went, okay, this is a little weird. And so I ran it through Valgrind, and it turns out Valgrind not only found a bad memory issue, it found a bad memory issue as a result of an API incompatibility that was based on like some C++ class, like a vtable thing. Like it was, and like it picked it out immediately. I was like, oh, the tinyXML lib is totally fucked. So I should probably link to the one that shipped, and that fixed it. So it will find things that are wrong just by the link step. So it's crazy. And as far as like weird things, as far as porting things, the one that I found as a recent favorite, I worked on a game called Murder Miners, which is basically like a Minecraft-y. Well, it looks like Minecraft, but it's like, it just looks like Minecraft, but it plays like Halo 1, which I'm a big fan of. I actually really like the Halo games, despite being a Linux enthusiast. And the weird thing that I found with that game is that the way that they allocated their sprites, because you obviously have different cube types, and what was happening is that the cube types were wrong. Like it was basically it was referencing the wrong sprite because it was I didn't know what the sprite sheet looked like, so I looked at it and I went, why is this off by 1? Because what it was doing is that it was off by 1, but only for certain blocks. And so I went, this is weird. And so I looked into shader, because what's interesting about their shader, because they had this running on a 360, is you think about like vertices as like you have 3 floats, 2 floats for texture, 4 bytes for color and things like that. So you'd expect like a 3D game to have like a 30 to 40 byte vertex. These guys packed it into 4 bytes. It was awesome. Like it was a really cool thing to see. You would not expect that from an XNA game to have this crazy level of optimization at the graphics stage. But the problem is that the way they were packing the sprite was it had 255, and you can actually do custom cubes if you wanted to. And it would do like 1 over 255, because there's 255 blocks. And I noticed that in because the way shaders work is that you have like 1 over 255 and you store it as a constant value in like a constant, I don't really know what the term for it is off the top of my head. But I noticed that because it was like 1 over 255, it has things like, point, whatever that decimal value is. And I noticed that it was off slightly, because the problem is that the way we print out floats to GLSL, it would do just %f, which is up to 6 decimal places. The problem is that because it was like 1 over 55, it turns out that the value that was being stored as the constant, because it didn't have this extra 3, was 1/10,000,000th off. And so what was happening is that all of the blocks, because it was 1/10,000,000th too small, was going 1 block back. Except for 0, because obviously it's 0, so it would be the right block there, but all the other ones were -1. And so I had to write a custom printf that actually did 9 floats and did it portably, because we had this weird locale dependency. And so we actually do print to 9, and that's why it works. But yeah, there are bugs like that, especially with floating point, because floating point is insane. Things that you think are trivial because it's 1/10,000,000th off will break an entire game. So that's one of the cases where I've found that just minor things, even from little behaviors like that, will happen. Luckily, it's usually just me that sees that, because I see way too many games. Those are my 2 favorites. Are there any other questions? Yes. Yeah, I'm still dependent on Mono right now. I'm hoping that Core CLR is good, because as soon as that happens, I'm ditching Mono so fast. When I found out they were actually shipping a runtime, I was hype. So I have no idea if it'll be good, but I'm sure as long as it's not Mono, it'll be good enough or better. So it's a pretty low bar for them to meet, honestly, because I find bugs that like the latest Mono runtime doesn't work on Linux for any program at all, because they have an assert that doesn't work. Like it clearly says what the problem is, but they just shipped it anyway. Like I see stuff like that all the time with Mono. So if there's an alternative, I'm very excited. Anything else? Well, we have a few minutes left. Do y'all have places to be, or can I goof off with a possible demo? All right, cool. So, anybody familiar with Fest Friday? Anyone? Okay, cool. So this will actually all be new. Neat. Let's see how I get this to quit. Okay, I think that worked. Oh, enjoy my Steam library once I mirror this. Assuming I do this right. Okay, cool. So I've been working on an update to Fez, and oh, is this gonna be cloud storage? Okay, cool. And basically what we've been doing is making it super nice. I should point out that this has nothing to do with portability. I just wanted to show it to people. But basically, what we've been doing is a lot of user experience things, particularly with video settings. If you're familiar with the video settings now, it's like resolution, window, I think there's a borderless toggle, and I can't even list how many. We changed that a little bit by adding a bunch of stuff like screen mode, scaling mode, VSync. We actually made a time step variable so you can actually run the game as high of a frame rate as you want and it will actually work. We added things like hardware instancing so the game is a lot faster. And there are things like the command line options that we kind of put back in as options instead of having to do weird things with a config file. And the one that I kind of want to show off, did I just quit? Yes, I did. I hit the wrong key. Luckily, this game is fast to load because we made it faster. Because one of the things we added is a single-threaded mode. And if your game is, because the thing is, if you're having a loading screen in your game, I just would like to point out that if you feel like your loading screen is taking too long, the reason it's long is because it's a loading screen. Does that sound weird to anybody else? Because it should, if you're thinking that this is a good user experience thing, because what you're doing by having a loading screen is you are doing this rendering, and at the same time you're doing things that you could be doing with the time spent rendering. And on top of that, if you're on VSync, if you render that frame, you're halted for possibly up to 16 milliseconds. And so the game will be a lot slower. And in the case of this, I actually have it in single-threaded mode because even on this MacBook, which is not that great, it actually runs so fast that there are no loading screens. Even though technically, by having single-threaded, it should stutter while it loads. But it's so fast without the threaded GL that it doesn't matter. We have it as an option in case your PC is slow and actually will continue to do the loading screens if it's slow. But I kind of it's going to do that the whole time, isn't it? Okay. Oh, that is a gorgeous frame rate, by the way. So here we have Fez, and it's running in a pixel-perfect mode right now. So if you look at the left, you'll see like those rotating tiles over there, or rotating platforms, I should say. And what we did is that we made some modes. Oh, hello. I think it's so slow that it is actually like breaking this setup. So that's actually one mode. And what we have is something called full aspect. And what it actually mimics the viewport of the original game, but scales it so that it actually will fit your screen. So if you have a really large screen, but it's not like 2560 by 1600, which would be a multiple of 1280 by 720, which is what this was targeted as, it will be, the screen is like way too far out and Gomez is really tiny. So what we did is we did full aspect, which I should also point out that all the letterboxing is gone. For those who are familiar with the game, we ripped all of that out. So no matter what aspect ratio, you will see everything without dumb black boxes. But you'll notice in the full aspect that because the field of view is as it originally was, the tile is now off the screen because the field of vision is a lot smaller. Of course, the problem is that you can't really see it on the screen, I'm sure, but like because it's scaling things in a weird integer value, if you look at Gomez's eyes, like if I just like randomly go left or right, he has this like weird thing where his eyeballs get like super big and then they'll get super tiny and then he has like crazy eyes just because it's like tiny pixels. And so what we did is we added the pixel perfect if you wanted to have it pixel at the right scale. And what we also did is we added a mode called super sampled, which rendered, instead of going, for example, if you're on 1440 by 900, pixel perfect goes to the scale at 1280 by 720. What this does is it actually goes up to 2560 by 1600, which is still pixel perfect, but then it scales it to the full aspect, so it's still the right field of view. The downside is that because you are scaling with a linear factor, which is how super sampling is working, rather than a point filter, which is how you got the weird eyes because the rounding was off, you kind of give, you can't see it on the screen unfortunately, but Gomez in this mode has like eyebrows. So like there's like, because it's linear, it like approximates like right here, it's like half black, half white. And so you kind of have these weird, we called it the eyebrow effect. But it was good enough to where we were able to give all three options to those who wanted pixel perfect with the right aspect ratio, and then just the raw aspect ratio. On top of that, unfortunately, I do not have a. Does anybody have a DualShock 4 on them by chance? All right, because what we did is, first of all, we have basically what we did is we actually now have an actual control option for the controller, so it actually will give you bindings just like the PC. But on top of having the proper prompts, it actually checks your controller hardware ID. And so if you plug in a PS4 controller, even during runtime, it actually will hotload the right IDs. So you can actually have full PS4 and PS3 support, and it actually does that with the in-game assets that are controller dependent as well. Because for the controller DB, we use it for the configuration, but there's actually something called joystick get GUID, and from there, I actually made an extension to FNA called get GUID-XT, and what it does is it takes the hardware ID, strips out all the OS-specific thing, and gives you a constant string. So I can even tell you that the PS4 string is 4C05, C405. It's the same way on all three. Yeah, I know. I've been doing this for too long. And so we made it hot load properly because we can actually detect with get GUID-XT at runtime those sorts of features. And yeah, an SDL game controller does help with that as well because, like for Towerfall, I actually use some things with game controller and the get GUID-XT extension to do all the many modes of controllers that they have for that because they have like arcade sticks and all that stuff. And there's one more setting I would like to talk about if I can remember what it is. Ah, yes. The setting that I don't have on the screen. I have to go into, oh yeah, enjoy my terminal. I'm making great use of this wonderful macOS interface. Settings, show, oh yeah, this is how you will do it if you actually do this in-game. Multi-sample option. So if you want multi-sampling, or you want to try using multi-sampling, you can actually do this by setting this value to true. And if we load the game, and it will not crash, I hope, because that setting is very experimental. It actually looks okay. So when we tried to do anti-aliasing, because there are a lot of like diagonal surfaces. Like if you go to the cube, sometimes they spin around, and so there's these weird aliasing effects that you get on them. And it also shows with a lot of the curved effects, like the Polytron logo, for example, is like really aliased. And multi-sampling actually fixed that, but there's a problem with that option. And I'll kind of show you with this option, assuming it works, and it's just going to keep doing that. This is why you don't depend on cloud saves in your game. So we have this room here where there's basically the idea is that you move around and you can, with the spotlight, you can actually figure out what's going on in the rest of the room. And so the problem is that when we enable multi-sampling, which is somewhere, okay, where'd it go? That's a little sad. The anti-aliasing, sorry. And so, first of all, anti-aliasing goes as high as you want. So if you have a graphics card that does 32 or 64 XAA, we actually support it natively. In this case, we're going to do 8, and the game is going to be wicked slow. And what you'll notice, basically what's happening is because what multi-sampling does is it really just blurs things out at the edges. And the problem is that in a pixel perfect game, for example, when you have lighting, you have this light buffer that is supposed to be pixel perfect with this other thing that is supposed to be pixel perfect. And the problem is when both things aren't pixel perfect, you get these weird blurring at the edges. And for the case of lighting, depending on the screen resolution, you'll actually see, like, above, there's a platform above, you'll see these edges that are blue that you are not supposed to be able to see. And so you actually get this weird, like, it's this weird effect like that. And so we actually didn't implement this in the final version, but we still have it as an option, because one of the things that's really nice about anti-aliasing is that if you go into spoilers, there's a 3D thing. If you go into the 3D mode, once this loads, because you have to go through the whole deal, because the problem is with the 3D mode is that if you go into 3D and it's fisheyed, so most of the edges are aliased. But if you have anti-aliasing on and you look at it, it's really nice and clear. It might look a little bit wonky up there, but in this case, everything's really smooth, and if you have really high anti-aliasing and it runs at 60, you can go in a really high resolution and just get these really nice screenshots if you want to take some with the anti-aliasing on. And you can just turn it off when you're actually playing the game. And so that's sort of just a sampler of the things that we've been doing with the game, and I've been writing about this on Google+. So if you go to the the slides and you go to my Google+ link, I have a bunch of stuff like that. I have some posts for V. I do some stuff for FNA as well. So if you're interested in like GL optimizations, I write about that pretty often nowadays. So I am definitely out of time. I'm amazed that no one has thrown me out, but I guess we have some extra time. So I will let you all get out of here if you want. I'll be around if you want to ask me a question off camera. Thank you all very much.